Good morning, my YouTube viewers. Crystal here. What I'm here this morning to do is I want to give you the solution to the Analytics Vidhya sentiment analysis competition. Basically, what I had done is I had originally taken their course on sentiment analysis, which I wasn't thrilled about that because you had to type in everything yourself. And I don't really see the benefit of typing in everything myself because you can make typing mistakes and then you have to spend time trying to correct your typing mistakes. And in addition to taking the course, I also looked on their website and they had published an article on sentiment analysis as well. But what I have done is I have used a much simpler version of the sentiment analysis. And I know you can't see it because my screen recorder only allows me to score one tab of the screen, so it doesn't allow me to record my entire screen. But what I'll say is when I first did the logistic regression with the sentiment analysis on the course I took with Analytics Vidhya, the first score that I got was about 55%, and then it moved it up to 56%. And I had a logistic regression with Lasso, and I updated the program to take out a lot of the stuff that Analytics Vidhya had put in there. And the reason why is because the more things that you put into the program, the more possibility of error you have. And with the logistic regression with Lasso, I had 73%. And then eventually the Lasso didn't work because apparently the Lasso doesn't work on logistic regression. But on logistic regression with grid search, I still get a 73% with logistic regression with grid search. So that's the one that I decided to stick with. That's the one that I'm going to be showing you, except for the fact that last night, late at night, I was doing a DNN, a deep neural network on sklearn, and I got 72% on the deep neural network, but that still was 1 percentage point lower than the logistic regression with grid search. So what I'm going to do here, without further ado, is I'm going to go over the solution with you. This is the solution that I came up with, and a lot of things that the Analytics Vidhya website had in it, I took out and made it much more simplistic because I like things simple and straightforward, and that's the way I tried to make this program. So my program is on the GitHub website, so you can see it right here. So you're more than welcome to go onto the website and look at the programs I have uploaded and follow along with me if you like. And it's the Short Analytics Twitter Sentiment Analysis. So the first thing I've done is I've given you the problem statement. Problem statement is the objective of this task is to detect hate speech in tweets. For the sake of simplicity, we say a tweet contains hate speech if it has a racist or sexist sentiment associated with it. So the task is to classify racist or sexist tweets from other tweets. Formally given a training sample of tweets and labels where label 1 denotes the tweet as racist, sexist, and label 0 denotes the tweet as not racist, sexist. Your objective is to predict the labels on the test dataset. Motivation hate speech is an unfortunately common occurrence on the internet. Often social media sites like Facebook and Twitter face the problem of identifying and censoring problematic posts while weighing the right to freedom of speech. The importance of detecting and moderating hate speech is evident from the strong connection between hate speech and actual hate crimes. Early identification of users promoting hate speech could enable outreach programs that attempt to prevent an escalation from speech to action. Sites such as Twitter and Facebook have been seeking to actively combat hate speech. In spite of these reasons, natural language programming research on hate speech has been very limited, primarily due to the lack of general definition of hate speech, an analysis of its demographic influences, and an investigation of the most effective features. So now we know the problem statement. So the first thing I did was I imported the libraries. And you can see the libraries that I imported. It's just a very small amount of libraries. So I decided that I'm going to change the way I import libraries from now on. So from now on, you're going to see the new way that I import libraries. The second thing I did was I loaded up the files. Now these files are on my GitHub account. You're more than welcome to use them. If you want to use them, they're there for other people to use. So you don't have to load them up on your GitHub account, and you don't have to load them up on your computer and use up valuable memory. The second thing I did was I looked at the train file, and you can see the train file has an ID, a label, and a tweet. We looked at the test file, and the test file just has an ID and a tweet, no label. So we look at our sample submission. The sample submission wants to see an ID and a label. The next thing we did was we wanted to check for any null values. So we put in code to check for any null values, and there are no null values. And then what we wanted to do is we wanted to see the shape of the train file and the test file. So the train file is almost twice the size as the test file. And then the next thing we wanted to do was we wanted to compare the tweets in the train file to the test file so you can see the comparison. And what we wanted to do is, the next thing we wanted to do is we wanted to see how many non-racist sexist tweets we had compared to racist sexist tweets. And that breaks down to 7%. Approximately 7% of the tweets were racist and sexist. And we have a graphical representation to show you that approximately 7% of the tweets are racist and sexist. The next thing we did was we're pre-processing raw text and getting it ready for machine learning. So we imported our natural language libraries. So like particularly the Porter Stemmer and the stop words. And so what we did was we took the stop words out of the train file and the test file. And the next thing we did was we made all of the tweets lowercase. We removed the word user from the tweets because the user is anonymized and it's not necessary. And then we removed the hashtags from the tweets. We also moved any words less than 1 character. I know I said they're less than 3 characters, but I went over here and I changed my mind and I made it 1 character. I just didn't update it on the program. So now you can see the train file. The train file has a new column called process tweet, and these tweets have been cleaned up. And the test file also has a file called process tweets, or a column called process tweets. And it's been cleaned up. Now, one thing I don't like is over here, they take on the hashtags, they take off like part of the word. And that's something that I really don't like. And I tried really hard to get rid of that, but I just couldn't seem to get rid of it. I'm not sure exactly what to do. So if any Python programmers, know what to do and they want to tell me what to do, I would be really grateful about that, because I'm sure that my accuracy could be higher if it didn't cut out the words. The next thing we did was we just put in a mosaic, put all the words in a mosaic so you can see all of the words that were in the tweets, like smile, people, new, go, feel, love, life. And so now what we have to do is we have to create our training and test sets. So we defined our X, Y, and X test. Y is train.label, X is train.process tweet, and X test is test.process tweet. And now what we do is we break our training data set down into X train, X val, Y train, Y val, using the train test split. And I decided to give it a test size of 10%, and also made stratify is yes, because if you have an imbalance, which we do have an imbalance, you're supposed to make stratify as yes. I wanted to see the shapes of the X train, X val, Y train, Y val, and you can see the shape is X train is 28,765, X val is 3197, Y train is 28,765, and Y shape is 3197. And then what we're doing is we're converting text to word frequency vectors using TF-IDF vectorizer. And so we changed the X train to train underscore TF-IDF. We changed the X val to val underscore TF-IDF. And we changed the X test to X test TF-IDF. And it printed off the first 5 words of the vectorizer, just so you'll know that it works. So what we wanted to see was we wanted to see the shape of train underscore TF-IDF, which now it's got lots of columns, because I suppose that they decided to make pretty much every tweet a column or every word a column. And val underscore TF-IDF has loads of columns too, and X test TF-IDS has a column as well. Sorry about that. My boyfriend's doing a video as well. And the next thing that we've done is we set up our smote because we have an imbalance of tweets, imbalance of categories. So you've got lots of zeros and not very many ones. And because you've got lots of zeros and not very many ones, we need to put in some synthetic sampling to try to bring our accuracy up. But what I found is that it didn't really bring the accuracy up. But we did set up our smote, and train TF-IDF resampled and Y train resampled goes into the smote. It becomes train TF-IDF and Y train ravel. After we use smote and then put in created train underscore TF-IDF resampled and Y train resampled, we defined our model. And in this instance, our model is going to be logistic regression with grid search. And so basically, selection is logistic regression, and selection fit is train TF-IDF resampled and Y train resampled. We've created our parameters for grid search, and then we've got grid search. And so the best model is CLF.fit train TF-IDF resampled and Y train desampled. And we've got loads and loads of warnings here, just pages of warnings, which I'll scroll down. keep going. Okay, so now I wanted to see the logistic regression score, and it gave us a 99% accuracy, which I think is really good. And so we printed the best penalty and the best C, and you can see that. And so now what we did is we're making our prediction on val_TF-IDF, and you can see the best model. You can see the grid search and all of the parameters in the grid search. And what we had to do is we had to do a little bit of work on this prediction to make it to fit into a file. And so the next thing we did was we predicted upon the X test. And we did the same thing to X test that we did to the prediction, and we called it test pred. And we submitted that into a file, and you can see that this is our output file, which an ID and a label. And so that completes it for the logistic regression with grid search. I hope you liked it. I also used random forest classifier that did not get as high an accuracy rate, and after random forest classifier, it didn't give me as high an accuracy rate, so I didn't even use it. The only one that I really wanted was logistic regression. So that completes this solution to the Analytics VidHaya Twitter sentiment analysis. This is a solution which gave me 73% accuracy, which was a higher accuracy percentage that I got when I filled out the article on Analytics VidHaya website, and I took the course. And the reason why is just because I just used something much simpler, because there are other more simpler vectorizers you can use, and I'm going to be experimenting with those to see if I can increase my score. But if any computer programmers see my video and want to give me some tips on how to increase my score, well, I'll certainly be open to them. So if you like my video, please like, subscribe, and share. If you like the work I do and you want to leave a donation, then I've got my email address in the description below. I don't have enough subscribers, so I'm not able to make money off the videos through monetization, so I have to ask for donations. And thank you so much for watching my video, and I look forward to making more videos for you.